Good afternoon, everyone, and thanks for coming, because this is the last session of the 2 days, so I presume everyone is very tired, so thanks for making the effort to come here. We are going to present on something that we've been working on the upstream, on a private model as a service. So, if you know Red Hat, as a company, everything we do is open source, so we do have the upstream mentality first, so everything we do is collaborate with open source communities together, and then we offer downstream enterprise-ready solutions based on that. Okay, so this is one of the ones we have been working on lately with different teams, not just us, also people who are in the audience from Red Hat as well has been working very hard on that. So my name is Marcos Entenza, sorry, and with me I have Jens. We are part of the product team at Red Hat working on confidential containers or confidential computing in general for OpenShift. OpenShift is our enterprise Kubernetes offering to run applications in a hybrid cloud. And today we are going to present on this. Many of the things we are going to talk have been told already during these 2 days, so I will try to go very quickly on the first part and leave Jens more time to present on the interesting topic, which is how we implemented this. So, as you have heard these days, most of the enterprise data is off cloud and regulated. And to get AI value from this data, basically you need to bring AI into your data. This is a phenomenon that we call data gravity, that is usually happening everywhere you have your data. Your applications are going to be running alongside your data, because for many different reasons. Doing this, it creates 3 parties with different conflicts. The model owners, as you have seen during these 2 days, that they want to protect, or they need to protect their model weights. We have the enterprise consumers who want to use those best possible models, but at the same time, they don't want to give their data for free. And we have, of course, the regulators. So we are coming from Europe, where we love regulations. So I can tell you that we do have a lot there. And basically, all these regulators, they want very favorable controls and not just promises. So each party is an adversary of the other. So the model owner usually doesn't trust the infrastructure. The infrastructure doesn't trust the workload. Think about AI agents these days. And the data owner doesn't trust the model owner. So this is the three-way trust dilemma that we have. So we can solve this problem just with contracts or with policies. And this is where confidential computing can help. I'm not going to go through this slide because you have seen this probably 20 times these 2 days. So basically, the data in use is the last paradigm of protecting data that we are solving with confidential computing. The 2 other states is something that we have solved for a long time. So let's talk about the regulators and a concept that has been mentioned as well many times during these 2 days, which is digital sovereignty. So there are 2 regulatory forces on digital sovereignty. On the left side, there are regulations where enterprise customers can't expose their data outside the country where they are operating. And on the right side, there are mandates that they are asking these enterprise customers to protect the data across the entire lifecycle. And you can see many different types of regulations on each country. They're listed. Okay, I think, as I said before, if you have been on any of the panels outside, Brittany was explaining this very well. What are the different regulations that are across the different countries? And each industry, doesn't matter where you are running, it will face each particular risk. And this is not just only reputational, but there are legal implications where you don't follow these rules. On financial services, for example, In Europe and EMEA, there is a DORA regulation specifically for FSI that is enforcing the customers to protect the data in use. Government defense, where sovereignty is not negotiable. Healthcare, which has probably the highest breach in cost in any sector on regulations, and telco, of course. And I think it was last year, there was some news about a Korean telecom company that exposed 26 million user unencrypted keys, and it was fined with a record fine of $97 million. So as you can see, these are very high risk that every single company, independently where they are running, they need to look after. So this private model as a service is, as I said, is an upstream community project that will provide an encrypted model that it will be published by each vendor. It will provide an inference server that can be run locally by the enterprise. And in this scenario, no operator or platform owner will be able to see any plain text on the model weights or on the data that is used with the AI model. So basically, using this model will provide sovereignty. Sovereignty is going to be satisfied. Model intellectual property is going to be protected, and data is going to be confidential all at once with just one solution. Okay, so this is the why, and Jens is going to explain the how now.
All right. So quick context maybe for those not familiar with our stack. So we use confidential containers. That's a CNCF project, and it basically wraps your Kubernetes pod into a confidential virtual machine provided by Kata containers. And the VM, in this case, is the trust boundary. Trusty is the attestation and the key broker service that verifies the TE before releasing the secrets. With that, so here's what the developer sees. We're talking about inferencing here, right? So this is an inference service. This is KServe. This is what the developer sees. A standard KServe manifest, and we add 2-3 lines, confidential enabled true, and a resource ID that is pointing to a key in the key broker service, as well as the runtime, which maps to the runtime class name in your OpenShift or Kubernetes cluster. And that's more or less it, 2 lines. On the other side, we have what security ops will configure behind the scenes. Trusty attestation policies, the RVPS, the reference values, the runtime class, model key registration. The developer never sees any of this, ideally. This is upstream KServe. PR 5382 actually was merged last week. The author sits here in the audience. Ivan, if you want to speak to him afterwards. It adds to the API, it adds a confidential spec, and the key point here is that the developer's workflow doesn't change with this. Developer workflow does not change. So developer just adds this small thing, and then security ops does the rest. It's managed by them. But what does the rest actually look like? Who does what in this scenario? So this is what makes the whole thing work in practice. We speak about 5 different personas. The model owner defines policies and holds the keys. The operational security team configures Trusty. They manage the attestation overall. They wire in the runtime class on the fly. They do basically all the heavy lifting. The developer deploys inference services using templates. They see the YAML that I just showed, but nothing more. The cluster admin manages nodes and schedules pods, but has 0 visibility into the TE memory. And the inference user, they just hit an API like they're used to. Here, the key insight is the developer never configures confidential computing. They can't, even if they wanted to. Operational security wires it in once, and it applies transparently to every confidential workload. The cluster admin, the person who's root on the host, is explicitly the adversary in this scenario. This is what the architecture, this is what confidential computing protects against. Most other approaches, or many other approaches in this space, assume that the developer drives security. And we think this is wrong. For enterprise adoption, it is wrong. In a regulated environment, security decisions like this should not be made by the person or the persona developing the inferencing code. So we talked about the personas, we separated the personas. Next I want to show you where these personas map into, or where they operate in the architecture. So the model owner over here, they sit there off cluster, basically. They encrypt the model, they define the attestation policy, they manage their keys. Trustee here is configured and maintained by the operational security teams, maybe your compliance team. They manage trustee, the attestation service, reference values. The developer, so their workload lands in this black box, basically, inside the confidential pod. This is a Kata VM running on a hardware TEE. Everything, KServe, Kata agent, the vLLM, all this runs inside this encrypted memory. The Kubernetes admin, they run this dotted line here outside. This is the Kubernetes worker node. This is untrusted. On the bottom, you see basically the overall flow. Encrypted model pool, then we have composite attestation data fetched from CPU and GPU at the same time. And eventually, after successful attestation, it will come to a key release. We'll walk through this flow step by step a bit later. But first, I want to talk about what happens when these personas work for different organizations. When the model owner and the infrastructure owner, the tenant also, they don't trust each other at all. So let's think about this for a second. So far, everything I've shown kind of assumed that the whole stack is owned by the same organization. In a real enterprise scenario, very often you will see that this is very different. There are three mutually distrusting parties, right? The infrastructure provider, the tenant or the customer, and the model provider. So the first question is, does the model owner trust the customer's attestation service? And that one question really splits this whole thing into two parts. On the left side, we have they trust it. On the right side, we have that they don't. So let's zoom in a little bit into this. The left branch from the previous page is the model owner trusts the customer's attestation. So then the next question would be, can the TE in this scenario reach the model owner's attestation, the KBS that does the verification? Can it reach this directly? And if that's the case, so they trust each other and it can be reached, then this is what we call in the passport model. And this is what works today, right? So the TE in this case, it attests locally, it gets a signed attestation token. Think of the attestation token like a passport. And it presents this passport to the model owner's KBS. The KBS is the key broker service. It checks the signature. It releases the key if everything is according. This is simple and proven. This is what works today. If no, the enterprise, let's say they restrict egress. I'm in a network-restricted environment. Here, what you can do is you could combine passport with a relay. So it's the same token still, but it's forwarded through a relay in the customer's DMC. This is in design at the moment. Now, the right branch, this is the harder case. The model owner, in this case, does not trust the customer's own attestation service. They want to verify the hardware evidence themselves, right? So here the same question applies. Can the TE reach the model owner's KBS directly? Then we're in this red box over here. That's what we call, or what I call multi-trust. So in this case, the model owner's trustee verifies the hardware evidence directly, not the token, the actual data that comes from the hardware. And both parties in this case can then independently attest the same TEE. And the customer for the data, the model owner for their weights. Basically, this is kind of the North Star. This is not supported today. Hardware supports it. The community is building towards it, I would say. In the yellow box, this is the if-no case. So here we are also in a network-restricted environment. In enterprise environment, this will typically, from our experience, almost always be the case. Here as well, you need a relay. And the relay, again, sits in a customer's DMC or at a network boundary, and it kind of forwards the hardware evidence again, not the token, the actual signed attestation report. So it forwards it to the model owner's trustee. And the model owner then verifies it directly, and if satisfied, they will encrypt the decryption key with the public key from the TE and send it back through the relay. The relay sees the encrypted key pass through, but it cannot decrypt it. It never had access to the private key. This one never left the enclave. And another nice thing about the relay is that also kind of all egress collapses here. It comes to this as a single point. It means you don't have to have a firewall exception or new firewall rule for every confidential workload that you run. So for most private model as a service deployments, this model, we think that the model with the relay is at the moment the practical answer to what can be done today. This is the end-to-end flow, really quick. This is the model owner side. What do they do? Well, they encrypt their weights. They push it to some form of storage, an OCI registry or some other form where it can be stored in encrypted form. It registers the decryption key in their key management store, and also they have to define an attestation policy. The policy will say things like which TE measurements are acceptable, which image hashes are allowed, things like this. All of this feeds into trustee, right? Policy and the key are ready now at this point. Now let's look at the deployment side. The model owner does this once, and everything that follows is automatic. So what happens when the developer deploys? And for simplicity, we assume that they will use kubectl apply for now. That's basically their one action. What happens next is that the storage initializer pulls the encrypted model, and the attestation agent collects hardware evidence, so both from CPU and GPU. And that evidence then goes to trustee, and trustee will evaluate the evidence against the model owner's policy. This is where the two flows converge from model owner and the deployment side. Trustee will then evaluate the evidence, and if yes, it will release a key. If attestation in this case is not successful, something doesn't match, maybe it's a wrong version of the firmware, maybe the GPU is not in confidential computing mode, this will mean that nothing happens. In this case, the key stays locked, and the data is never decrypted and never is in any danger of being accessed. Again, the decryption key in this case would never leave trustee unless the attestation is successful. This is, well, there's many work streams going on, of course, in this area. I just picked two. One is in KServe. The first part is done, I think. The PR is merged. What needs to happen next is to get this into a release and then get users, and users giving feedback, and then we will iterate on this, right? The second part is what I discussed, the cross-domain attestation. This is an active discussion in the CoCo community, and this is where I invite everyone to contribute, join the CoCo community for these discussions in Slack, or we have weekly meetings where we discuss these kind of topics. Also, if you have something in this area, we are very happy to have you in the meetings and have you present to start a discussion with the CoCo community. And with this, so yeah, just all of this is like upstream open source code, of course, right? Kata is Open Infra Foundation, CoCo and Trusty are in the CNCF. We have many contributors from many companies, NVIDIA, Red Hat, Intel, Alibaba, Fortanix, and others. So yeah, please join. Maybe 3 things to take away from this talk for you. One is that this trust problem in like on-prem AI with private models, maybe foundational models, is like fundamental. That's what Max said. It's like you cannot configure your way out of this with RBAC and things like this. It needs confidential computing. Then private model as a service is production ready for the use cases that I've shown. There are, I would say, the multi-trust case is still something that we need to work towards. But this is usable today. And if you take one URL from this talk, I would recommend the CoCo GitHub. This is where we discuss an issues where the pull requests land, both for the guest side components and for the attestation side. All right, and that's it. The conference is almost over, but we're still around. So if you have questions, please ask, or you ask now. Otherwise, find us in the hallway or ask us questions. Yes?
So on the first level, the owner has the model, and you said you provide a owner reference and put it on a trustee, right? Mm-hmm. So in order to do that, the model owner needs to have equivalent containers, GPUs, CPUs, in order to produce hardware, signed keys, signed hash values. So you're expecting the model owner to have the CoCo there as well locally in order to generate that. So that's part I'm confused.
Okay. So okay. So the question was, do we expect the model owner to provide, if I understand correctly, do we need to expect them to provide the hash data of their container? Yeah. So, and yes, they need to provide this, and they need to also store this. They need to give this to their security ops team so that we can later on compare both, right?
So in other words, the model owner need to have a similar CoCo infrastructure locally before handing over to the services.
They just need to have the data that they produced in their build pipeline, basically. The artifact data that they produce there is what they can feed into Trusty in the attestation server.
Not just the data, because in order to do the attestation, you have to have generated the hash values. You have the essentially computational VM equivalent.
Yes. So you.
GPUs, you have the CPU and the GPU, and then produce that signed hash token, and then put it on a trustee. So basically, essentially, if I gave to, say, you're the infrastructure, you have an infrastructure, but I have an equivalent infrastructure to produce that value.
Mm-hmm.
So that's kind of a burden to the model owner.
It is in the sense that, yes, you need to. So the question was, it's not just the data of the container that I need to feed. I also need to have the data from a similar or an accepted hardware environment, basically, that gives the same attestation report. But as the model owner, what I need to know essentially is that the attestation policy was accepted, right? And that can be, what I need to know is that it is running in a confidential environment that is accepted by maybe my security ops team. They consider this, I have this certified set of servers, they we expect this level of firmware, we expect this level of CPU, and then so basically this part needs to be it just needs to be in a confidential environment that is not out of date, right? Yeah. Yeah.
The practical sense that, essentially.
Yes, I understand. Yeah, there's some organizational overhead. That's what you're saying. Yes. Yeah.
So you were mentioning the build pipeline. So essentially, you need to have some mechanism in the build pipeline, whatever build pipeline you're using, to perform the pre-calculated measurement of the UKI that you're loading in.
Yes.
So that you can provide the pre-calculated measurement to Trusty beforehand.
Oh yeah.
Otherwise, you can't know if it's the right number.
Exactly. Yeah. So, that's what you were getting at too, right? Yes. So in your software production pipeline, this is where you can get these data, and in this pipeline, you can already feed that into the reference value provider service.
Yeah, I understand that this, you needed to do this, just kind of.
Yeah.
If I just have a model, I want to post it.
Yeah, but it's something that it is something that needs to be done. That's right, but it doesn't. Like you as a developer don't necessarily have to care about this part.
Well, if I am the model owner, suppose just hypothetically,
Mm-hmm.
I'm not really tech savvy.
Yes.
Now I have to
Yeah.
learn how to build the VM, get the attestation report, and then define the policy. So that's a big hurdle for me, right? Because I already trained the model. I just want to give to you.
Larry.
So my recommendation for that problem is to open a pull request in the VRT project for SNP gets, because we need to do this anyway. Sorry.
It's a great project.
We need to add functionality to consume UKI images to generate that, so you don't have to. You want tooling to pre-exist. That's what I'm hearing.
Yeah.
Yeah, so VRT currently has support for both PDX and SNP. I don't know about GPU yet. I think so, but that is something that we need to be at.
Yeah. So another great project to contribute to. All right. Are there any other questions? I think. All right. We're also almost out of time. Thank you very much.